All right. So we're going to pick right up where we left off at. We got through all of our vocabulary, which was great to see during third period. So now we're going to go ahead and take a look at these 4 examples that we have here. So for this first one, I'm going to show you 2 different ways to do it. And then I'm just going to kind of alternate as we go. Example 2, example 3, and I want you to try to pick one that would work for you, okay? Now, a couple things that I want to make sure that I talk about. First of all, we are not looking for just a common multiple. We are always looking for the least common multiple. We're looking for the smallest one. So one thing that I do want to throw out, though, because we're going to talk about this next week when we start adding and subtracting fractions, all right? One way to always find a common multiple between 2 numbers is to simply multiply those 2 numbers together. Okay, so I can tell you right now that if you were to take 8 and multiply this by 18, you guys all have calculators. What is that? What is 8 times 18? It's 144. If I made my list long enough of all the multiples of 8, 144 would be on it. If I list my multiples of 18, 18, 36, 54, 72, 90, 108, blah, 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 144 would also be on that. But here's what I'm going to tell you. It's not my smallest one. And that's what our goal is to find today. So when we get to fractions, some people are like, well, my teacher always taught me to do this. It works, but sometimes you're going to find numbers that are not your least common multiple. You're just going to find a common multiple. So, method number 1, when it comes to finding the least common multiple of 2 numbers, and this is the one that we practiced earlier. We had 8 and 12 up here during third period. Okay? Just start by listing your factors. Now, here's the thing. I can't tell you when to stop because I don't know how big or small these are going to be. All right? Now, here's the one thing I can tell you. We don't have to go above 144. But I don't even think we're going to have to go that far. All right? So, what's my first multiple of 8? 8. Because that's 8 times 1. 8 times 2, 16. That's my next number. And I'm saying this because sometimes people are like, how did you find the numbers? We're just multiplying all of these numbers out. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. Then we'd have 40, 48, 56, 64, and then it keeps going. And if I need to come back and create more on my list, I will. But for right now, that's what I'm going to go with. What's my first multiple of 18? 18. Okay. Then my second multiple should be 36, because 18 times 2 is 36. My next multiple is 54. Then what? 72. None of these have started to repeat yet on both lists, are they? Means I'm going to have to go back up and extend this one. What's my next one? 90. Then we'd have 108. And again, I might need to add to that list if I need to, but I definitely need to go up and add to my other one, don't I? Okay. After 64, we'd have 72. That's what I'm looking for. I finally have a number that appears on both lists. So, my smallest common multiple between both of these 2 numbers is 72. This is now my least common multiple. Okay? As you practice these more, I'm going to be honest, this is the method that many of you probably are going to prefer. Okay? Now, I want to show you the other method. And the other method has to deal with factor trees and prime factorization. Okay? But there's some additional stuff to it. Okay? So, we already know the answer to this problem is 72, as we alluded to. It couldn't be bigger than 144. We've already confirmed that. So, here's what I want to show you. And again, this might not, it's not the shortest, I'll be honest. It's definitely not. But for some of us, this is a good place for us to get started. Let's start with the prime factorization of 8. 8 can go into a 2 and a 4. And 4 goes into a 2 and a 2. There's my 3 prime numbers. Okay, 18 goes into 2 and 9, and 9's going to go into 3 and 3. Okay, at this point, I'm hoping we're pretty comfortable doing prime factorization. Now, 8 is 2 times 2 times 2. Okay, come on. And 18 is 2 times 3 times 3. Now, what you're going to begin by doing is finding out what these all have in common. These two lists have what in common? They each have a 2. Do they have anything else? No. This 2 is going to come down here. Now, if I were to stop right there, what does 2 represent? This is my greatest common factor. This is what we practiced for the last couple of days. But we're looking for the least common multiple. And this is the part that I think is kind of cool. I didn't realize this until I started teaching this class 6 years ago. If this is your greatest common factor, you can find your least common multiple by now using these numbers as well. We already have our 2 down here. What I'm going to do is I'm going to bring down everything that I haven't marked here. So this 2 is going to come down. This 2 is going to come down. This 3 is going to come down here. This 3 is going to come down here. Does everybody see how I got those other ones? Okay, grab your calculators and multiply those 5 numbers together for me. Nope, it shouldn't be. It should be 72. This, all of these factors multiply together to give me 72, which is my least common multiple. Again, now that you've seen the answer to this, I'll take that. Thank you. Now that we've seen this, I'm going to repeat what I did. What I have in purple, this is my what? Greatest common factor. Then everything that is not part of my greatest common factor came down, got multiplied together, and that all of that multiplied together now gave me 72. Okay, so again, this is not really anything, not teaching you a new strategy. I'm just telling you, this is what we've done in the past. Before we ignored these 4 numbers, now we're taking these 4 numbers and we're pulling it down here as well. Okay? All right, let's flip it over. Let's take a look at the back. Okay, so we're going to do one more of these that's just numbers. Here's what I'm going to ask you to do. I want you, and I'm going to give you about a 3-minute head start. Pick whatever method you're leaning towards and work through it trying to find your least common multiple. If you want to start listing, start listing. You want to do your prime factorization, start doing that. I want you to pick one of the 2 methods we just got done showing, and I want you to try it with 6 and 20 before we move any farther. Yep. So then 10 divided by 2. Which gives me 5. Okay. So now we're going to write 6 equals 2 times 3. And then below it, we're going to write 20 equals 2 times 2 times 5. No, you got an extra 2 in there. So we'll start with what they have in common. Okay, we're going to pull that down here. If we were done, that's all they have in common. This would be my greatest common factor. Now you're going to pull these three down, and that's going to help you find your least common multiple.
Times 2 times 5.
Well, times your, I usually start up here. I still have a 3, and then I have a 2, and then a 5. It's not 12, it's 20. I was like, how did she get 36? Now, you forgot a 2 up here. So 20 should be 2, 2, and 5. There needs to be another 2 with that. So what do you have?
6.
Okay, is 6 a multiple of 20? So then it can't be my least common multiple. Okay, something to consider as I'm walking around. And again, I don't want to confuse us, but we need to have this conversation. Megan, please. When we found greatest common factor, if I ask for the greatest common factor, I'm going to go back to these two numbers. The largest possible answer is 8. Because there's no factors of 8 bigger than 8, correct? Okay. When I'm looking for my least common multiple, what's my smallest possible answer? 20. Because what's my first multiple of 20? No, 20. Multiple means my numbers are getting bigger. So I cannot have a least common multiple be 6 or 12 or 10 or 18. The smallest it could be is 20. And here's what I'm going to tell you. It only can be 20 if 6 goes into 20. Does 6 go into 20? No. That can't even be my least common multiple then. It's got to be something bigger than that. So your greatest common factor can't be any bigger than 6. Your least common multiple can't be any smaller than 20. Question? Okay, but if they have a 2 in common, you don't pull them both down. You just pull one of them down. All right, so almost everybody, not quite, but almost everybody, what do you have for your answer then? Almost everybody I've seen has been doing this using a factor tree, so let's take a look. 6 is going to go into 2 and 3. Okay, those two are both prime, so that factor tree is complete. Okay, 20 can go into 2 and 10. 10 goes into 2 and 5. All of those are prime. That's where we're good there. Now, I'm going to write 6 over here as 2 times 3. I'm going to write 20 as 2 times 2 times 5. Okay? We begin by finding what they have in common, which is right here. So I just pull this 2 down. Again, if we were to stop right there, this is my what? That's my greatest common factor. That's the biggest number that goes into both of them. Okay? But now we bring down what else we have encircled. We bring down a 3. Then we bring down our 2 and our 5.
I call those the leftovers, and like least common multiple starts with an L, so that helps me remember. But
I forgot that I brought those down.
So our least common multiple, 2 times 3 times 2 times 5. 60. Megan, question.
I see what I did.
Okay, now, here is the one common error that I saw for people who did this. Some people got 120. And here's how they got 120. They brought down both of these as two twos. When you find what they have in common, you only bring one of those down. Just like we did when we did our greatest common factors. Okay? Now, here's, if I were to do the list idea, and I'm going to throw this out there because for some of you, you're going to like this way better. When I do a list idea, I'm doing it in my mind, but I'm doing both of them at the same time. But I always begin by taking my largest number, 20. What is my first multiple of 20? 20. Does 6 go into 20? Okay. What's my next multiple of 20? 40. Does 6 go into 40? No. What's my next multiple of 20? 60. Does 6 go into 20? There we go. But you have to know what you're looking for. It's not, some of you are going to be like, oh, that's way shorter. Yeah, if this makes sense to you, but if it doesn't, then you've got to go back your other route. So I don't create a list of both of them. I look at my largest number, and I start thinking of the multiples of that number, and I find the smallest one of those that 6 goes into. Okay? Again, I don't want to overwhelm you, but here's my goal. I don't want to give you one way only. That's what you're locked into, and you never find another way to do these problems. Okay, I'm trying to give you multiple ideas to think about. What I don't want you to do is this. You can't start picking and choosing pieces I like here, pieces I like here, pieces I like here. You have to pick a method and go with it. Okay? Especially if you're like, I don't know if I can do this. If you can't do this, then you got to get good at this. This, to me, if I'm thinking about it like in terms of level of proficiency, this is probably level 1. Creating lists is probably level 2. What I just started discussing over here is probably level 3 or level 4. Like, you got to have a pretty good understanding of why I did what I did over there works. You can't just try to guess it. All right. Now, we're going to wrap up today by looking at 2 of them with variables. And as we found out the other day, even though we kind of get worried because, oh, variables are going to make things more challenging, that this often doesn't. So, we're going to start with 12 and 18. Okay, so, just like we did before, we're going to ignore the variables to begin with. 12 is going to go into what? 2 and 6. 6 is going to go into 2 and 3. Okay, 18 is going to go into 2 and 9, and 9 is going to go into 3 and 3. All right, so when I go to rewrite 12x, it is 2 times 2 times 3 with 1x. When we go to do 18x squared, 2 times 3 times 3 times x. So where are we going to begin? We're going to begin by finding what these guys have in common. Tell me what they have in common, Megan. They've got a 2 here. That's going to come down here. They also have a 3 in common. That's going to come down here. They also have a x in common. That's going to come down here. If I were to stop and multiply those all together, 2 times 3 is 6. This would be 6x. What is this representing? My greatest common factor. Okay? We have to, though, pull everything else down to find our least common multiple. So, I have a 2 up here. I have a 3 here. And I have an x here. Grab your calculators. 2 times 3 times 2 times 3 is 36. X times x is x squared, because I have 2 of them. This is my least common multiple. What?
I thought you said we couldn't bring both, like, the ones, oh, never mind. We couldn't bring it to.
You can't bring, so when you circle these, you don't bring 2 2's down, you bring 1. This 2, Delaney, came from the fact that I have one I didn't circle. Does that make sense? And that's where this other 3 came from as well. Now, I'm going to go back to this idea over here. Out of these two numbers, which one's the biggest? 18. What's my first multiple of 18? 18. Does 12 go into 18? No. And if I don't know, I just use my calculator to find out, right? What's my next multiple of 18? 36. Does 12 go into 36? Yep. That would be my greatest common factor between the two numbers. Now, you'd still have to take care of your variables, but this would be your greatest common factor of those two numbers. All right. You guys try D.
You mean least common multiple?
Or sorry, least common multiple, yes. All right. Now D, please notice I threw 3 variables into this. The first one's got an X and a Y, the second one's got an X and a Z.
So then would you add on
Okay, where are you getting all these 2's from though? 4 goes into 2 and what's 4 divided by 2?
2?
So that should be a 2. And then you're done.
Oh.
Good. That looks very good. Let me see. Okay, how'd you get that?
Well, at the end of the day, that 4 every time you have the same multiple, where if 4 times 5.
Okay. How'd you get your YZ squared?
Instead of x, I would just have done the factor tree like I would have done.
Okay, but then that's not matching up to what we would have done now. Okay, this has got a Z in it. Make sure you understand the difference between your Z's and your 2's.
Oh wait, that's supposed to be Z.
Those are
I don't know why
Z's.
I did Y.
Yes. Okay, here's one thing I'm going to point out as I walk around. Some of you have 2's and you have Z's, and you don't know the difference between them after you wrote them down. So I'm going to give you a suggestion. I like to put tails or lines through my Z's. Okay, because I used to run into the same problem. And so I'd have equations. When you get like into higher level math in high school, you have equations that have 3 variables, X, Y, and Z. You need to be able to tell the difference between a Z and a 2, because if not, you could go a long way down the wrong path and realize, oh, that should have been a Z, not a 2. So let's begin with our 4. First of all, 4 factor tree goes to what? 2 and 2. Nice, short, easy, to the point. 10 is going to go to what? 2 and 5. Again, I'm not giving you huge factor trees here. We're trying to use this with numbers that aren't super, super complex. It's not like I'm telling you, find my least common multiple of 80 and 96. Okay, that's going to get really large really fast. Now, 4xy can then be written as 2 with an x and a y. 10 xz squared, and this is what I mean by I draw my line through the middle of it, is going to be 2 times 5 times x with 2 z's on it. Begin with this. What do they have in common? 2 and an x. Those are both going to come down. Again, if I were to stop right there, what is that?
2x.
Well, it is 2x, but what's it represent? Greatest common factors right there. Now, I'm going to bring down what I haven't brought down in this one, which is a 2 and a y. And I'm also going to bring down what I haven't brought down in this one, which is a 5 with 2 z's. Now, my numbers and variables are kind of scattered through this, but it shouldn't matter a whole lot. 2 times 5. 20. Okay, how many x's do I have? 1. How many y's? 1. How many z's? This is my least common multiple. Again, if we were to go back to the number idea, choose 10. What's my first multiple of 10? Does 4 go into this? Okay, what's my second one? Does 4 go into this? There's my least common multiple, at least number-wise. Okay, variables, I got to figure out something. And again, I'm not going to tell you the way because there's more than one way. I need you guys to find a way that you're comfortable with and be able to find these. Questions on the back page of this? So really, if you think about everything we did last week and everything we did this week, it's centered around prime factorization, factor trees, and finding what things have in common and not in common. All right. Assignment for tonight is going to be this. Page 191. Numbers 3 through 23 odd to begin with. And then we're going to go 29, 31, 33, and 35. All right, and we are out of here at 35. So you've got a little over 10 minutes for you to get a start on that.